Have you ever really stopped to think about how something complex, like a car or a computer, actually gets made? Heck, even a simple snow shovel. We're talking about potentially thousands of individual parts coming from all over the world, all showing up at the exact right place at the exact right time. It honestly feels like magic, but it's not. It's all thanks to a masterfully coordinated plan.
So really, how does it happen? How does a massive factory know precisely when to order some tiny, specific screw or bracket so that it doesn't shut down an entire billion-dollar assembly line? It's got to be one of the biggest, most mind-bending logistical puzzles in the modern world.
Well, the answer lies in what's called a master playbook. You can think of it as the ultimate game plan for a factory. It's this incredible document that takes a high-level business goal and just translates it into a perfectly timed, perfectly synchronized sequence of actions for every single component. So let's peel back the curtain and see how this playbook actually works.
We're going to walk through this playbook step by step. We'll start with the high-level master plan, then we'll look at the recipe for a product. After that, we'll see how every single part gets planned out, follow the product through the final mile of its journey, and finally, we'll wrap up with why this whole playbook is so incredibly important.
All right, first things first, the master plan. Before you can order a single part, the company has to decide what it's actually going to build.
This is where something called the Master Production Schedule, or MPS, comes in. Now, this isn't just a wish list or a suggestion. It's a firm statement, a commitment of what will be produced, how much of it, and exactly when. This is the official build schedule, and the entire factory is held accountable to it.
And this is such a key distinction to make. You've got the sales forecast, which is really just an educated guess about what customers might want to buy. But then you have the MPS, which is a firm commitment to what the factory will build. The manufacturing team isn't responsible for meeting a guess. They're on the hook for hitting the numbers in the MPS.
So here's the bottom line. The Master Production Schedule is the starting gun for everything else. Every single decision that follows, every purchase order, every work schedule, every shipment, it's all driven by this one single top-level document.
Okay, so now we know what we're building. The next logical question is, what does it actually take to build it? In other words, we need the recipe.
In the world of manufacturing, that recipe has a name, the Bill of Materials, or BOM for short. It's this super detailed hierarchical list of every single thing you need, from the big sub-assemblies all the way down to the tiniest screw, to make just one unit of a finished product.
Let's break this down with a snow shovel. It's a great way to see how this works. At the very top, level 0, you have the finished snow shovel. To make that, you need two level 1 components, the top handle assembly and the scoop assembly. But wait, that top handle assembly is itself made of level 2 parts, right? The wooden handle, some nails, and a bracket assembly. And it goes even deeper. That bracket assembly is made from level 3 parts. You see how it's all nested together?
And this structure, this hierarchy, is everything. It's a detailed map that shows the precise relationship between every single component. Without this kind of breakdown, it would be literally impossible to figure out exactly how many of each part we need to order. So how does the system use this map? Well, that brings us to the real brains of the operation.
All right, this brings us to the engine room of the Manufacturing Playbook, Material Requirements Planning, or MRP. This is where the serious number crunching happens.
So what is MRP? You can think of it as a giant calculator. It's a system that takes that master plan we talked about, combines it with a product recipe, the BOM, and then spits out a perfectly timed schedule for every single nut, bolt, and piece of raw material. Now, to do its job, the MRP system needs to know 3 key things. First, it looks at the MPS and asks, what are we supposed to build and when? Second, it looks at the BOM and asks, okay, what ingredients does it take to build that? And third, it checks the inventory records to ask, what parts do we already have sitting on the shelf? But here's the real magic of MRP. It doesn't just calculate grand totals. It plans everything out over time. It uses what's called a time-phased record, looking at all the requirements week by week to figure out not just what to order, but precisely when it needs to be ordered. Okay, let's walk through this together. It's simpler than it looks, I promise. Look at week 5. The system sees a gross requirement, that's a demand coming up, for 35 of these brackets. But if you look at the projected available row, we only have 27. Uh-oh, that's a shortage. So to avoid shutting down the line, the system works backward in time, accounting for the lead time, how long it takes to get the part, and it generates a planned order release in an earlier week, in this case, week 4. This makes sure the new parts show up just in the nick of time. And now for the coolest part.
This calculation is then exploded, and that's the actual term they use, down every single level of the bill of materials. So, the plan to build the final snow shovel creates a demand for the handle assemblies, which in turn creates a demand for the brackets and wooden handles, and so on. It's this beautiful, perfectly timed cascade of requirements.
Okay, so the factory has done its job. The product is built. It's a thing of beauty. But our playbook isn't finished yet. Now we have to actually get that product into the hands of customers, right?
This final stage of the playbook is all about that journey from the factory door to the store shelf. This is what's often called the final mile. And this part is managed by a system called, wait for it, Distribution Requirements Planning, or DRP. And if that name sounds really familiar, it should, because it uses the exact same time-phased logic we just saw in MRP. But instead of planning parts for a factory, it's planning finished products for the entire distribution network.
So what's the big takeaway here? DRP is the critical link between the highly controlled, planned world of the factory and the messy, unpredictable world of real customer demand. It's the system that makes sure the right number of products are in the right warehouse at the right time, ready to ship to a store near you.
So we've walked through the entire playbook, from that high-level plan all the way to the final delivery. You might be thinking, wow, that's a lot of complexity. So why does it matter so much?
Because when you get this right, when this playbook is perfectly synchronized, the benefits are huge. Companies can hold way less inventory, which saves a ton of money. They see fewer shortages and delays, which means better customer service. The products you want are actually on the shelf when you go to buy them. It's a massive win-win, a huge boost in efficiency for the company, and a much better experience for us, the customers. It really is the hidden engine of the modern economy.
This playbook, in one form or another, has been the absolute bedrock of manufacturing for decades. But as we rocket into an age of artificial intelligence, machine learning, and on-demand everything, it raises a really fascinating question. Will this incredibly complex, human-driven playbook one day become fully autonomous? Will it just write and rewrite itself in real time to respond to our changing whims? Now that's something to think about.